All right. Good afternoon, everyone. Suppose we can start. Could we have somebody confirm if you can see me? I mean, if you can see my screen, and also if you can hear me. Okay. You see some thumbs up, so that's a sign which is good. Minute. Okay, sorry about that. I think I lost my connection there. Some weird reason it appears I don't seem to have my. There we go. All right, so we're going to continue our discussion of ICT 3020. I believe we've gotten to a stage where we've provided some context about the course. So in terms of how the course is going to be administered, I believe when we when we had class the other day, we I don't know what's happening here. When we had class the other day, we actually finalized our discussion of administrivia, and when we're looking at the process, that when we're looking at the course introduction, in essence, the things that we're going to be discussing in the course, right? I did mention that this is a very bulky course, quite bulky actually. Not really as technical as some of the courses that I have probably taught you in. It's supposed to be practical, hands-on course here, but the thing is that we assume we already know how to program, so the only time that we expect you to to do some programming is during the implementation of prototypes associated with the various projects that you're going to be working on. Okay. I hate this feature where I don't like grouping applications for some weird reason. It almost always is the case that by default they have to be grouped or something. Yeah, so today we're going to transition to module number, I mean, this is called module number 2 really, but it's supposed to be module number 1. I almost always use the very first interaction as as module number 1. And if you remember, I'd hinted at the fact that the lecture series is actually broken up into modules, not topics. So what tends to happen is that we have quite a number of topics covered in each of these different modules, right? Most of the students will tend to complain because the slide decks associated with the different modules are quite lengthy. If you notice, this is slide 1 of 341 or something like that. But it doesn't matter even if we cannot do that here. All right. So just to remind us that I don't know why this thing was not changed here, but a reminder that the My goodness, I actually have downloaded the wrong slide deck as well. But a reminder that we have the very first assignment is kind of ready. I'm going to put it up on the Moodle. The expectation is that this thing is going to be open tomorrow, right, which is Monday, and it will be due on Friday, right? So yeah, between now and Friday anyway, you will be expected to self-organize into groups of 5 individuals, okay? This shouldn't really be difficult because we've done this before. If you remember in 2034, we were doing more or less the same things, right, when we're working in various groups. So we're essentially going to do the same thing, self-organize into groups of 5, and then beginning, I guess, Friday this week, I'll also make available the topics for the topics that we are going to expect each of the groups you're going to self-organize into to actually pick, right? So you'll be given a list of topics from where you'll be expected to choose a preferred topic as a group, ideally, okay? I don't know if I can just use this. It appears downloading it in PDF is becoming a bit of a problem, which is not okay. So same drill. There's a link to a spreadsheet that has been made available, and you will be expected to self-organize into groups of 5 individuals, not 3, so 5 individuals, and then at a later stage you will be required to decide or to choose a topic, ideally. Okay. So the module is going to be organized as follows. I mean, I thought I would kind of use an example of a project that I was involved with. I almost always use real-world examples that I'm associated with to give us a sense of what the module is about here before we actually start looking at software process activities. And then after our discussion of software process activities, we're going to start looking into at software process models, ideally, right? After which we shall there we go. After which we shall gloss over how we cope with change, and then finally how we continuously improve software process, the software process itself. Right, in essence, the SDLC. What are some of the things that we tend to do to improve the process? Okay. Yeah, and then so again, remember that this module is tied to what I said would be covering in module number 1, right? Even though it's tied as module number 2. So a while back, myself along with a colleague of mine who is based in the UK. We are tasked by the Jesuit Centre for Theological Reflection to design and implement a research data management infrastructure. And if you look at their publicly available terms of reference, so terms of reference in essence is just a document that is made publicly available to whoever would be interested to bid on an advertised project. So in this particular case, the JCTR comes up with terms of reference, and then they make these TORs publicly available. People bid, and then they award the bid to a group that they feel is better positioned to actually work on the task, right? So it just so happens that we were given the contract ideally, right? And really the terms of reference were aimed at expecting contractors to actually work towards the following objectives. So we're meant to identify gaps and opportunities as they relate to a typical research, data management infrastructure. We're also expected to create a research data management or RDM framework, ideally, after which we would, design and implement the framework itself. And then afterwards, we were supposed to train staff on how to use this infrastructure. And it's quite common actually when you're developing software on behalf of an entity for you to, it's quite common for you to train them on how to use the piece of software that has been developed. It's usually included as a very important task done after you deploy the piece of software. So when you're costing, you take into account the cost associated with training ideally. Okay. Yeah. So our interest, as I'm walking us through this case example here, is really on the implementation of the framework. So in as much as the project involved other things, I'm just going to walk us through the process we went through to implement this RDM infrastructure. It turns out that your typical research data management infrastructure ideally is expected to be associated with certain key aspects, and chief amongst them actually is the so-called data management lifecycle. So what you're seeing on the diagram is your typical data management lifecycle. It has distinct phases, right? Where if you're handling data, that is, you're expected to first of all come up with some sort of plan, you document, and then you come up with mechanisms to protect the data. You figure out how best you're going to store the data over a long period of time. Ensure that you have provisions in place to make the data open, so that whoever is interested in accessing the data actually does have access to the data, and then you preserve it over a long period of time, right? So that's your typical research data management infrastructure. And incidentally, this whole notion of research data management has become important, right? And so a number of funding bodies increasingly will require the entities they are funding to demonstrate that they actually have in place your typical research data management infrastructure. So a place where data that is going to be collected during research will be made available, right? This is a piece of software or pieces of software to facilitate this whole process, right? So ideally, the implementation of this RDM framework was meant to be aligned with the research, your typical data management lifecycle, right? In 6 phases. And then more importantly, the infrastructure to be set up was supposed to take into account the quote-unquote FAIR principles. So FAIR is just an acronym that stands for, the F stands for findability, so the data is supposed to be findable, so whoever would be interested in finding information should easily search for whatever they're looking for, should easily be accessible, as and when required, it should be interoperable, and it should be reusable as well, right? So the thing here is whatever we were expected to implement here was supposed to be aligned with the quote-unquote FAIR principles, okay? Now, at some point here when we, when we got to a stage where we're conceptualizing the solution, we came up with the following solution description. We broke apart our proposed solution into 3 distinct parts. And these 3 distinct parts may not be intuitive here, but they're aligned with these 6 phases here. These 3 distinct parts involved research planning, so a series of activities and tasks that would be performed when you're planning to conduct research. The active state of research component. So after you plan your research and you start collecting your data, you have a series of activities that are performed, right? You collect your data, you process it, and you analyze it prior to sharing it, right? And then so the last component was sharing results, which would include activities like publishing results and then decommissioning of the project. Now, again, this may be a bit confusing at first for you because, one, which is actually the only reason, I guess, is you don't really understand this space, right? You have no idea what research data management is all about. And that's typical of software projects. a client will come to you. It could be it could be that the client is looking at developing a piece of software to be used in the financial sector, and you may have no knowledge of how the financial sector works, right? Your task is to either find a project team member who is going to act as a domain expert, or you read up and understand that space. Usually, most entities or software development shops will prefer the latter, right? Where you do your own research and you start understanding the space you're working in. The consolation is, however, it's not always the case that you'd have to read up, because usually what most of these organizations will do is they'll specialize in certain types of sectors. So it could specialize in building software to be used in the higher education sector, for instance, or software to be used in the financial sector, or something like that. I have classic examples of certain entities that I know of, like if you look up entities like Hobbiton, I think. You'll find that they, I think last time I checked, they were based in Kalundo or something. They've specialized in the financial sector, right? And stuff. Anyways, so there's that. No, there we go. Right. So you notice here that these three different components here have let's call these corresponding. These are the stages involved in each of these different processes. So 2 stages here: project proposal stage, project startup, and then in here you have data collection, or collect data, process data, analyze data, and then you have publish results, and then decommission project. Yeah, and then again you have what you might want to call like sub aspects, right, of each of these different 3 entities. Ideally, this is important because in as much as the goal is to develop a piece of software, but initially what you'd have to do is conceptualize the thing that you're building. This can be done early on in the process if you understand what you're doing, or as part of the design process after you gather the requirements. Usually a lot easier if you do it as part of the design process, or the design phase, ideally. Okay, so again, as part of the so this is, you can view this as being like a component, a very informal component diagram, if you will. And then what you have here is like an architectural design of the final solution. So in essence, what we did was we got this as input and came up with an architectural framework, if you will, right? What's perhaps crucial here is an appreciation of the fact that we are mapping these 3 phases we introduced as research planning, active state of research, and sharing results, 1, 2, 3, to specific software platforms, right, that would handle all activities associated with that particular phase. And so we realized that the framework that we were implementing, or that we were expected to come up with, was not really going to be holistic, but it would be represented by a series of tools and services. So we realized early on that the DMP tool, for instance, would be better placed to help us handle the research planning, right? And then the active state of research could easily be handled by what we called a digital asset management system, okay, DAMS. And then sharing of the results would actually be handled by a repository platform, ideally. Yeah. You'll notice that there are these, dotted lines here as well. The idea here was that in as much as we were providing, or we're going to implement or make available specific tools would actually be could potentially be rather, the stages themselves could potentially be handled using other avenues, like sharing of results, for instance, could be done using the website, right? And also JCTR's social media channels, ideally. Right. So again, this is a solution description. This is something that you tend to do during the design phase. Ultimately, right? We came up with a solution description. This was the goal. We implement the RDM framework. We came up with a solution description, this and that. And then finally, I don't know, there's a bit of background noise here from Ms. Hope. It'd be nice if we could. We're going to mute them, I guess. I don't know what's happening there. And then ultimately what we did was we came up with implementation, right? The implementation, what you're seeing here is implementation of the DAMS platform, digital asset management system. And then we have the repository here. There's no screenshot for the DMP2 here because it was essentially just the reusable component. Yeah. Now, the thing here, the thing to appreciate is we have like a solution, right? A description of the solution and the actual implementation. The question to ask is, what do we do in between, right? What series of activities and steps do we have to undertake for us to get to the final stage, which is implementation of this and that? Well, it turns out that one of the very first things we did was we had to plan, right? We came up with a detailed project plan that outlined a series of activities to be performed. A simplest possible thing or artifact you can use for that is a so-called Gantt chart, right? So you come up with a Gantt chart that will have specifics regarding the timeline of the project, for instance, and details of who exactly is going to be responsible for each of the different aspects of the project. This is a simplified version of our timeline here. If you notice, we're saying the actual plan itself included the plan, the detailed timeline, the details of the individuals that are going to work on the project, and quote unquote potential risks associated with the project. Right, all of these are used as input, right, to plan for the project itself. Now, what's perhaps very important is the very first point here, where we initially committed to say we would actually finish this project within a period of 2 months, right? So initiation of the project was going to be 1st December, and then we were expected to finalize everything by 9th December. It turns out that we had to kind of like extend or stretch the timeline here, mostly due to an availability of people that were supposed to elicit requirements from Nigeria. Okay, and then in terms of the detailed work plan, yeah. So remember, this slide outlines the key things we took into account when we were planning for this project, right? So the work plan, team composition, and then issues to do with project management. The work plan is expected to be as detailed as what you're seeing on the screen right now. I'm not sure if it's, yeah, so it spans 2 pages here. And because we had committed to doing this in 2 weeks, you notice that we're breaking apart the period into weeks, is it? I don't know if you can see here on top, we have the month, October, November, and December. And then right below here, we have 4 weeks for each of the months, is it? And the idea behind this plan or this Gantt chart is we are identifying each individual activity to be performed together with a description of what that activity is, right? So you will notice when you start looking at project management that we will make a distinction between the generic task from a milestone and a deliverable, right? A task is like a thing that you do, right? A deliverable and a milestone are things that you do, but they're special types of tasks. And they're special because the duration is always 0. In other words, you do them right there and then. So if you're looking at a deliverable, it's like the date indicates when you're going to deliver that product, whereas a milestone is like a key event in your timeline, and it indicates when that event is going to take place. So duration is always 0, right? Whereas for these other tasks, the start date is different from the end date. The start date and the end date are the same for a deliverable and a milestone. And we'll discuss those things a bit more here. What's perhaps important here is, if you look at this artifact, is the fact that there is diamond symbols here. These indicate quote unquote deliverables and milestones, right? The idea is supposed to be distinguished from your normal task, which is this shaded, grayed out rectangle here. There are a couple of other things that are missing here, but we'll get to that at a later stage. Like, for instance, the dependencies, right? You can't immediately notice which tasks are dependent on which existing tasks, for instance. Anyways, so this would be your timeline. And the expectation really is that in your project chart and your proposal, you would actually have this detailed timeline, and you present it to your client, and perhaps they'll interrogate it and offer comments or something. All right. And then, so we got to a stage where we came up with a plan, but the question to ask as well is, well, what process, what software process model are we going to use for us to get from the solution description here to this, the implementation itself? If you remember, during the introduction, I mentioned that there's a broad spectrum of options to choose from, is it? In fact, I hinted at the fact that there's a whole module dedicated to, well, topic, I guess, because our discussion of software process models is part of this module. But the series of topics that we're going to look at tied to different types of software process models. In case you've forgotten, I highlighted things like the waterfall model, Scrum, feature-driven development, spiral model, rapid application development, RAD, there are a whole bunch of them. What we decided to use for this JCTR project was quote-unquote Scrum. So Scrum is a variant of, it falls under the broader confines of a family of software process models called agile techniques or approaches. And it turns out that Scrum is one of the most widely used agile software process models, right? One of the fundamental ideas around techniques like Scrum or agile techniques is that you deliver the product iteratively, right? So in this particular case, we are saying we're going to build this platform over a span of 3 months. So what we did with Scrum is we look at the 3 months and then we break apart the 3 months into what are called sprints, right? So maybe each sprint will be a week in duration, right? And the idea is every week, it could be a week, it could be 2 weeks, but the idea is in each sprint, right? In this particular case, every week, we are providing the client with a partial representation of the system, some version of the system, not complete, but some functional aspect of the system. Okay, that's the idea behind this software process model. But what's important here is we decided to work with Scrum. We could have decided to work with a spiral model. We could have decided to use a waterfall model, but we chose Scrum. And you probably appreciate why we chose Scrum when we get to a stage where we look at the factors that you take into account, probably in 2 weeks' time, maybe 3 weeks' time, the factors we take into account when we are deciding on whether we should use a waterfall model, integration and configuration, Scrum, feature-driven development, Kanban, right? A spiral mode and all those things, right? Anyways, rapid application development, or is it RUP, Rational Unified Process? There's a whole range of software process models that you can choose from, ideally. Anyways, so hopefully this gives you an idea, right? I mean, I could sit here and give other examples. For instance, I can perhaps use an example of our research group, our research group website, to give you an indication of what process we went through to build this. Looks simple like this, but behind the scenes, right? There's a lot of thinking that went into how exactly do we render people that are associated with this research group, right? And when we render these people, what sort of information should we provide about those people, right? How do we render the publications associated with this research group? Okay, well, how about the various projects, right, associated with the research group and stuff? It looks trivial here if you look at it from the front-facing part of this web application. I won't call it a web application, not a website really, but if you were to look at the back end, you begin to appreciate you begin to appreciate that this thing here is complex-ish. Although, hint, hint, we actually used integration and configuration of software reuse, right? So this thing is powered by Drupal. So I've just logged into the backend, and the backend is where you configure stuff, and you add data and you update content and all those things. Anyways, so in essence, that's a classic example of how you would actually go about steps you take for you to implement a software-centric project. And really what we're doing in 3020 is to learn how to plan for such a project, right? And it turns out that the planning is best done by following through with the phases associated with what I introduced as the software development life cycle. In fact, our discussion of software process activities is essentially going to be a discussion of the SDLC, right? The idea is simple here. The activities that you undertake when you're developing software can typically be viewed as interleaved sequences of sorry about that connection issue there. I'm tethering, and there's a call that just came in here, which is a bit weird here. Anyway, sorry about that. All right. So typically these software process activities that you undertake or execute, right, when you're working on a software-centric project, will be composed of interleaved sequences of technical, collaborative, and managerial activities, right? This is a key thing here. And the goal is obviously to specify, design, implement, and test the software that you're building. Now it's a thing here, right? When you're just getting started, you typically have this illusion that software engineering is just all about writing code, right? That's not true. The writing of the code, the process of writing code it's a technical activity, but it's one of many types of activities that you undertake, right? There are collaborative activities that you have got to take into account. Managerial activities, things like how exactly are you going to manage the different people that are working on the project? It's usually the case when you're developing software that you'd be working with a large group of users, so you'd have the people that are developing the software, programmers, you'd have business analysts, the people that are handling requirements and all those things. You'd also have quality assurance engineers, right? People that are going to be helping you with testing of the software and all those things, right? So in essence, the key thing here is that you typically have a lot of people working on the project, and those people have got to be managed in a certain way, right? And because you have a lot of people working on the project, there've got to be mechanisms in place to facilitate collaboration. People have got to work together effectively, ideally. Anyways, so these it turns out that these software process activities, there are quite a number of them, but they can be segmented into these phases of the SDLC, where we can map them onto the SDLC lifecycle. They can be mapped onto specification-centric activities, so activities that we involve or associated with requirements, anything to do with requirements, right? So elicitation of requirements. prioritization of requirements, validation of requirements, all of those things will be tied to specification, right? There are activities that are tied to the design. There would be activities, there would be activities like coming up with the architectural design of the piece of software you're building, right? Various views of the software, actually. Deployment view, for instance. A model, a business process model of how data is going to flow into the system, right? The activity diagrams, for instance. Then you have development-centric activities, right? This is where the coding comes into play. So anything to do with the actual code base or the source code that you're developing, programming, for instance, version control would be tied to development. And then also things to do with verification and validation. So anything that will involve testing of the software that you're building can be clustered into verification and validation or testing, right? And then finally, evolution. Now, the thing here, right, is a couple of things here. There are a number of activities involved when you're building software, a lot of them, right? Those activities can be clustered into these phases of the SDLC. The other interesting thing is that these phases of the SDLC here are organized differently depending on the type of development process that you're using. Now, in actual thing about this development process as a software process model. So in other words, right, if you say, well, what we're going to do is we're going to do what Lighton and Nelson did with the JCTR project, and we're going to use Scrum. Scrum will organize these phases of the SDLC: requirements elicitation, requirements specification, software design, right, implementation, testing, and evolution, differently from the waterfall model, right? It's the same activities, same group of activities. You still do specification, you still do requirements analysis, design, implementation, testing, and evolution, but the sequence of events, the sequence of the activities, how you undertake the activities, those are different, right? The what and how is different. It's like if we want to go, it's a weird example, nothing to do with software, but it's like I want to go to town. There's different approaches you can take, is it? You can take a Yango, you can take a bus to town, you can cycle to town, you can walk to town. The end goal is the same, right? You are walking to town. It turns out if you're cycling to town, the way you're going to get to town is going to be slightly different here, right? I don't know if that's making sense here. So for example, classic example here is in the waterfall model, as you soon discover, these process activities are organized in sequence, like a waterfall, right? You're stepping through the waterfall, the steps of the waterfall. The idea is that you cannot work on activities, subsequent activities before you finalize previous activities, right? Whereas the other alternative is if you take an incremental development approach, you have a situation where you quickly cycle through the different activities, right? Anyways, we'll look at these software process models soon, probably in a week's time or 2 weeks' time or something. But the thing here is, the question to ask is, well, so if we have a lot of activities and we can segment them into these different phases of the SDLC, what exactly happens in the SDLC, right? Well, the first phase of the SDLC is requirements engineering or requirements analysis. And the current diagram showcases the sequence of events, the things that happen as part of requirements engineering. What is important here is that requirements engineering comprises of sub-phases which involve requirements elicitation and analysis, requirements specification, requirements validation. In fact, we can even throw in the mix requirements prioritization. Right? What is crucial is that the end product of requirements engineering is, like a key output of requirements engineering is a document that is called a requirements document. In fact, the correct name of the document is the software requirements specification document, the famous SRS document. That's the end result of requirements engineering, right? Yeah, so it turns out that with elicitation, what you're doing here is you are, as the name suggests, to elicit is to gather, is to get or to collect. So you are collecting, you are gathering, or you are eliciting the requirements. Yeah, so the gathering or collection or elicitation of requirements can be done using different techniques. Again, there's a dedicated lecture where we look at the different techniques, the pros and cons for the different sort of techniques. But you can gather requirements by observing, right? I'll give you an example. If UNZA comes to me, for instance, or they come to you and they tell you, we don't want students to clear manually. Right now, you get a form. I don't know where you get those forms from, and then you start going to lecturers' offices, is it? So that they sign. That's a clearance process, right? There's a form. They sign against a course or something to indicate that you've been cleared in that particular course. Also, somebody can come to you and say, we want you to automate the process. So you build software to help students to clear. Now, before you can build the software, right, you need to understand what the software should do. You may have some idea of what the software should do, but for you to confirm your assumptions and all those things, you need to go and interact with the stakeholders of the software you need to develop. Right? So interaction with the stakeholders is what we are calling elicitation of requirements or gathering of requirements. So in the example I'm giving about clearance, what I can do to understand what goes on is I can observe students, is it? I will go and camp at the library, observe what students do when they're clearing at the library. I'll find time and go into one of the lecturers' offices to try and see what students do when they're clearing an individual course. And maybe go and camp in the, head of department's office to see what happens there, right? I'm understanding the workflow. What I'm doing is I'm taking advantage of a technique called observation, right? I'm observing. Another approach would be, well, I am going to create some survey, right? Some questionnaire, and then I'll distribute it to a sample, a representative sample of students, right? Students, let's say in the School of Engineering, School of Education, School of Natural Sciences, right? And then I'll ask them questions related to what I'm building, a piece of software, so that I better understand this. And then afterwards, I'll analyze the results and hopefully come up with a comprehensive set of requirements. The other option is I can interview them. Now, I'm going to pause here, right, and remind you that if you were paying attention in 2034, these elicitation techniques, the things we are referring to as elicitation techniques, are the things we refer to as measurement instruments in 2034. It's the same thing, right? For you to interact with people, as you're interacting with people, there have got to be standard instruments that you use to collect data you're looking for. However, there are other things that perhaps we may not have discussed, not perhaps, but things we didn't discuss. Like I have an example there of prototyping, right? So you can take advantage of prototyping, right, to gather requirements. So the idea behind prototyping is simple. If I'm building a piece of software for, let's say, clearance, right, student clearance, what I could do is early on in the process, I build a very rough representation of the piece of software, very rough representation, and then I use that as a probe, right? Hopefully this is making sense here. I use it as a probe. So the interesting thing about the prototype is there are different types of prototype. Again, there's a whole discussion of prototypes which we're going to have. So this prototype can be a paper-based prototype, right? Or it could be a piece of a prototype that is somewhat functional, right? If that is making sense. But anyway, the key thing here is when we're eliciting requirements, we use a number of techniques, right? And we're going to have a discussion of those techniques. Our goal here is just to understand the things that happen in these different phases of the SDLC. And then As part of requirements engineering, we also have requirements specification. The idea of specification is simple, right? When you are gathering requirements, you would represent these requirements in a notation that is easy to understand to the average person. Like, want the piece of software to enable a lecturer to verify that the student has been cleared by adding a comment or something like that. Now, that notation uses human language notation, but it may not really be intuitive to a programmer, a technically inclined person, making it a bit ambiguous and perhaps difficult to translate it into code. So you need to convert it into a form that is going to be relatively easier for a technical person like a programmer to understand, to convert it into code. And you see that your specification document will have very weird notation like your use case notations, for instance, and all those things, right? Anyways, so that's requirement specification. All you're doing really is you're mapping the requirements that would have been gathered into a formal requirements document, all right? And then you have requirements validation, where what you do really is you look at the list of requirements that you'd have gathered, and then you assess whether they are achievable, for instance, or if they're comprehensive, if they're complete. It's like, I want the software to enable a lecturer to add a comment. That's a bit vague here, right? So you'd have to probe a bit further to make sure that that requirement is a bit complete here. Achievable in the sense that in some instances, there will be requests that will be made, right? That may not be possible, right? Anyway, sorry about the noise. I'm broadcasting from home here, and I think there are people, and the baby is crying here. I'm even tempted to pause for a little while here. I hope the noise is not too much here. The baby has just started crying here. I think I need a new plan here. Anyways, so that's requirements engineering, is it? If you've been paying attention, we're saying as part of requirements engineering, or this thing here in red, what do? You elicit requirements, you come up with a formal specification, the requirements, you validate the requirements, you prioritize the requirements as well. And the end product, the key product, the end is a requirements document or a software requirements specification document, right? Now, I guess now would be a good time for me to go back to the example that I started with, the JCTR example, right? Where we're building this research data management infrastructure, if you remember. Well, there are all these different phases, right? That were mapped onto this piece of software we're developing, if you are paying attention. These two tools here. The question is, how did we gather requirements? Well, or how did we go about requirements engineering with JCTR? I don't know if I have, probably don't here. I'm just going to have to speak to these things here. But for us to do this, for us to gather requirements and stuff, one of the things we did was we organized, we had a workshop initially, and as part of that workshop, we brought in all the key stakeholders from JCTR. JCTR is made up of different departments. At least at the time, it was made up of different departments. We brought them together, and then we're brainstorming on what exactly would need to be incorporated in the piece of infrastructure we're building, is one thing. The other thing we did was we conducted interviews with specific unit heads, they're called. And this is a part where I get to sometimes get to see if I can find some examples. I don't know if I have specific examples here. I want to see if I can find, probably not. I want to see if I could find me. I don't know if I'll be able to find that here. anyways, I wanted to showcase some of the things that we were doing here, right? I remember there was a time. It turns out the key person, one of the key people I was working with, quite a bit here. One of the key people I was working with was based in the UK, and because they were based in the UK, I can't hear. Because they were based in the UK, it was difficult, yeah, for them to participate in the requirements elicitation process. So I'm the one who handled the elicitation part of the project itself. I will look for the examples of interview transcripts. There were instances where we had visual interactions, for instance. It was quite interesting and exciting. Anyways, I don't know if there are thoughts or questions about requirements engineering. I'm going to pause here. The next time we have class, we will continue with the other phases of the SDLC. If you've been paying attention, you will notice there's a hand I see there. But if you've been paying attention, we are saying that we've started our discussion of software process activities. And then as part of the discussion of software process activities, we started off with requirements engineering, right? And we realized that requirements engineering involves elicitation, specification, validation, and prioritization of requirements, right? So when we meet next, we'll transition and start to look at what we do when we are busy with software design. Then we'll go to implementation, and then we'll go to testing, all right? All right, any question? I think there's a hand up from Ms. Banda. I guess it was raised by accident or something. Okay, if there are no questions.
Sorry, yes. Sir, I have a question. At the beginning, you did mention to say research data management infrastructure need to be implemented and aligned with the data management life cycle and the FAIR principles. And one of the principles among the four, you said the interoperability. Then I would love if you can shed more light on that one.
Right. So the idea behind interoperability is simple, right? It's when you build software, it's usually the case that software is expected to interact with other software tools. I'll give you an example of SIS or Moodle, right, at UNZA. Moodle at UNZA is interoperable with SIS. Why? So that enrollment into Moodle courses is automated, right? It's automated in such a way that you use the same credentials from SIS. The moment you register, you automatically gain access to the Moodle. Mobile money applications in Zambia are interoperable. Interoperability is centered around this notion of exchange of data. I can send money from my MTN mobile money wallet to an Airtel number. Why? Because Airtel money is interoperable using MTN, is interoperable with MTN money. In fact, if you've noticed, the interoperability, by the way, you probably haven't noticed this, but when you're sending money using these mobile money wallets, there's usually a message that comes through like NFS or something. That's the National Financial Switch. So all of these transactions go through the National Financial Switch. Right? So interoperability is just nothing more than exchange of data. And in fact, these days, virtually all applications are interoperable, is it? When you're logging into Facebook, there's that option, log in with Gmail or something like that. So interoperability is nothing more than a process through which different software applications can exchange data or can speak to each other. Yeah. Okay. Any other thoughts or questions about some of the things we covered here? That's interoperability, sir.
The other questions are concerning the requirements. Requirements engineering. There is one point you put across to say. For example, when you are dealing with data, when you are working with these softwares, you need to specification, meaning you need to define you need to define what the program will do, or which, or let me just say, the program that you are developing, is it going to manage the problems of the people, the problems that the clients are facing? Now, is it that, for example, you have developed a software, then that software is failing to say or to sort the problems that the people are facing within the community? Is it that you can be given another chance, for instance, to by the institution like Zambia, the research institutions? Is it that they can give you guidelines on how to come up with the proper software, or maybe it's you, for instance, as students, or maybe when we start dealing with these software development tools, is it that you yourself, being our lecturer, are you going to provide with maybe one of the tutors, or maybe one of the expert who is going to be helping us on how to handle these issues?
Well, great question. And the simple answer is that that's why we're actually learning about software engineering. Those are the things we're going to learn about. If you are paying attention, I think one of the things I mentioned was that what we're going to cover in this particular module is process improvement and coping with change. It turns out, right? The question you're asking is quite important, right? It's like, how do we ensure that the thing we are building is a match with what the user expects? There are two ways of doing this, right? Oh, one easy way of doing this is when you are gathering the requirements, you make sure that you spend a lot of time, understanding what the client actually wants. So you talk to them extensively, and usually it's recommended that you use a software process model that emphasizes, that places a lot more emphasis on requirements, in like the waterfall model, right? So extensive planning involved, and you spend a lot of time gathering requirements and refining the requirements. That's one approach. The other thing really is that what typically happens is, as you're going through these different phases, you're interacting with the client. If you're doing business and there's a client involved, you usually have got to sign off certain documents, right? One of the things that you have got to do early on before you even start serious development is, if you're using a waterfall model, for instance, is you agree with the client. We are done with requirements, and these are the list of requirements that we have gathered after interacting with the key stakeholders. Please sign off and indicate that we have captured all the requirements. And usually that sign off, by the way, is tied to some payment, right? Usually they'll say, we'll pay you 20% after you're done with requirements or something like that. So that if they come back and claim that the thing that you've built does not include the requirements, you go back to the document that was signed off. Say, but listen, we agreed that this is what we would implement. If you look at the software, all of these features that were captured have actually been implemented. Now, in terms of giving a chance, they could, but obviously that has cost implications. So you, again, have to agree with the client. If, let's say, you build the software and you agree with the client after you gather the requirements that these are what you're going to implement, and then later on down the line, because, I mean, change is the only constant, they say, is it? Change always happens. Because things have changed, they come back to you and tell you, well, there's this thing missing. If there's something missing, the software has got to evolve, right? If it's evolving, you're going to have to gather requirements associated with whatever is missing. You modify the design, you rewrite the code, and you retest. When you're doing that, you're spending more time doing that. When you're spending more time, that's more money. And because it's more money, the initial amount agreed upon may not be sufficient. So there are negotiations that will take place, and maybe the client will agree to pay you extra money for that. You understand this? There are other approaches on how you can sort out this. It's a serious problem, by the way. What your question is also tied to a concept called scope creep, right? Where things will be introduced, is it? As you are writing the software, there are new changes that are being integrated or something. What you can do is you can use a software process model that allows you to incrementally or iteratively deliver value to the client. So as you're delivering value, let's say this week, we're going to deliver hopefully that answers your question. Hopefully that answers your question.
Yes, thank you so very much, Doc.
Okay. Are there any other questions, by the way, folks, about this? All right. If there are no questions, I will see you. I think I don't know if we agreed Tuesday or something. I have to check. I think it's Tuesday or something. Thank you very much, everybody, and enjoy the rest of your Sunday.